try this. So let's see, OBS is starting now, and we can go live on YouTube. It's going live, going live, going live. Hello, we're live, and thank you for joining me at another Clojure study group. My name is John Stevenson. This is the Practicalli channel, and I'm focusing on lots of videos to help you understand all sorts of different aspects of Clojure and some of the tooling as well. I also use a very nice powerful editor called Spacemacs, which I've got some videos on how to use that as well and make the most out of doing Clojure development with that. So this week we are going to do another 4Clojure exercise. So 4Clojure is a website that has a whole number of challenges. I think there's over 160 challenges on there, and some are very simple, some are a little bit more involved. The one we're going to do today is a lot more involved. It's quite procedural in nature, so it's quite an interesting challenge to try and figure out how to do this in a very functional manner as well. So we're going to walk through doing it in a quite long loop-recur approach, and then we'll try and use some of the abstractions in Clojure to actually make that easier as well. So again, 4Clojure does help us understand the core functions and help us try out some of the core functions in the Clojure language. And please feel free to reach out to me during the broadcast for the chat, and if you have any other questions as well, then you can reach out to me via the Practicalli study group. There is there's a website, we've got the books, I've got screencasts as well, and probably the easiest way is to get hold of me via the Clojure in Slack community, and there's the Practicalli channel and the study group ones. If you've got specific ones, you can probably just use a Practicalli channel for everything, it's easier. And you can also reach me on Twitter and via GitHub. You can see all the content I've got on GitHub as well. And if you want to help these broadcasts, then please consider donating to or supporting me in any one of these changes by subscribing to my channel, sponsoring my bike ride, or just any financial donations you feel are appropriate as well. Okay, let's get on with the show. So all the code for today is already up on this 4Clojure 4Clojure repository, and that's for FOUR, and I'll put that into the chat for you as well. And yeah, so you can actually go and clone that if you haven't already, or just look at it on the website. And I'll push any changes we make as we go along up there as well. There's some other 4Clojure ones we haven't covered yet, as well as every video that we've covered there is already there. The code's already there for you to go around and play with. But there's also there's a few that we haven't come to yet as well. Okay, so let's have a look at the problem for today. And yes, here we go. So this is 4Clojure number 53. And it says it's the longest increasing subsequence. So a sequence, we can so in Clojure we can represent a sequence as a vector with the square brackets, or with a list. In this case, these are all square brackets. These are all vectors. Well, we're going to just treat them like sequences. So in this case, sequences of numbers. So we've got numbers, so it's like lots of different numbers inside the vectors, and we want to be able to find the longest increasing subsequence, so a smaller part of the sequence. So you can probably see for this one that 0, 1, 2, 3, that's consecutive, because it goes incrementally through integer numbers from 0 to 3. But this one, then we start at 0 again, so that's not part of this subsequence. It kind of sounds, actually, although I said it was quite challenging, I thought this one would be fairly straightforward, but it turned out not to be the case. So let's walk you through what I did. That's not the right file, is it? No. There we go. Let's go there. That's the right one. Here we go. So it does say difficulty is hard, and I think that was accurate. It wasn't straightforward. So let's deconstruct the problem a little bit. So yeah, it did take me a lot of things because it's kind of very iterative because you are like stepping through is one. It's like I've got a value 1 and then there's the next value bigger. Well, no, it's not. Okay, well that's not, then the subsequence is only 1 and we have to start a new subsequence, and so on. So you have to compare each number to the last number, as you need to keep some kind of state, and then you also need to keep a track of how big your sub sequence is getting as you're building it. So we iterate through the collection of values and keep a record of each subsequence as we go. This suggests keep state for some kind of thing, so we need to keep some idea about which is how big our sequence has got as we're creating it. It would be better if we could try and figure out how to basically transform the data to a more relevant shape structure, and then hopefully it would make like a simpler function, and we will by the end we'll see that that's possible, although it wasn't quite as simple as I'd still like, but it's a lot simpler than we do with loop-recur. So the basic algorithm itself is quite simple. We just want to find the subsequences that are consecutive in a given collection, so that's fairly straightforward to kind of work out. There's no kind of complex maths involved in that. So we've got 1 by itself because the next one would be 0, and that's less than 1. And these are consecutive, and then 0 is less than 3, so that's by itself. Although 4 is bigger, it's not 1 bigger than 0. So again, so we start off with the consecutive sequence there. So this is probably the trickiest bit, is actually coming up with the pattern that we actually want. So we're going to dive into that in a second. If there are any questions, feel free to put them into the chat and I'll try and address them as we go along. So let's have a look at the REPL experiments. So what do we do? So kind of did step through a very what turned out to be quite a long loop-recur function. And this is not all fitting onto the screen, is it? No. Let's see. Let's get rid of me. There we go. I'm going to get rid of all that stuff at the side because we need the full kind of thing for Spacemax there. Okay, I'll keep that one for now. Okay, where is my... There we go. So we're going to iterate through the... we've got a function here. I'm just using the fn simple form function because that's what 4Clojure takes. In a normal application, I'd probably have this as a defn rather than fn. And so we're calling our function longest sub, and we're giving it a collection. So that's our argument, and then we're going to create a loop so we can iterate through the collection. And our loop's going to consist of 3 local names, and these names will be updated each time that we go around the loop, because we'll use a recur function to call the loop again, but passing it new values for any of the local names that we're defining here. So we've got 3 local names. We've got temporary sub, and that's the sub sequence that's being processed, and the sub collection is the any kind of subsequence found, and the remaining collection is basically our guide about how far we've got through the collection. So we're initially passing the whole collection to remaining collection, because at the start we have to process all the numbers, The temporary sub and the sub collection, well, we haven't done any processing yet, so we're just giving those empty vectors to start with. And so if we passed in an empty collection, then we would just return like an empty collection, because that would be the longest subsequence. So so what I mean is, if we have that as our collection with nothing in there, it's a perfectly legal value in Clojure just to have an empty collection. We're going to return the empty collection because it is the longest subsequence. Just like if we had 1, 2, 3, 4, 5 in the if we have 1, 2, 3, 4, 5 in the collection, then that would be the longest subsequence. We would pass that back as well. I guess I wonder if there would be a test for that. Interesting. Oops. And so we need to check to see if there are values we need to process in this loop, and this also helps us create a breakpoint for when we need to get out of the loop, because if we don't have a breakpoint in the loop, then we'll go round and round the loop forever and ever, and possibly chew up all the memory in my computer, which is not good. And then if the remaining collection is empty, then we're just going to return this sub collection. So this sub collection is going to represent what the longest collection longest sub collection we've found is actually going to be. So I guess I should really call that the longest sub collection. And then if the remaining collection is not empty, so this is the true path, and then the recur is the false path. So we got a simple test. So if it's empty, then we're just going to get, if the collection that we've processed, we've come to the end of that collection. So if our collection is 1, 2, 3, 4, 5, and we got to 5 and processed that, there'll be no more left in the remaining collection. So we just return what we found as the biggest collection in sub collection. And then if that's not true, if we've still got more values to process, which we have right at the start, then we do a recur. And this is what we're trying to do now, is to come up with values for each of these 3 names that will be used in the next kind of loop that we go through. So we're trying to work out what the temporary sub is. So basically we're trying to figure out is there a consecutive sub sequence that we can build here. So if we've got a temporary sub that's empty, so if that's equal to empty, then we're going to just get the first of the collection. So we get the first value of the collection, and it returns that inside a vector, essentially, because that's the kind of structures we're looking for. If there is a value in temporary sub, we want to see if the next value is 1 higher. So we're increasing the temporary sub value. So we get the last value in the subsection that we're building up, increase that, and is it the same as the value that's in the collection, the next value we're processing? And if it is, then we just add it to the temporary sub. So basically add it to the collection we're building, and then if it's not the same, it's the same test, then we're basically just getting the first of the remaining collection, because we're building we're actually creating a new collection here, because it's not the same. So like when we're going from 0 to 4, then they wouldn't be the same, so we would start a new subsequence. And then we're just comparing whether the subsequence of the temporary sub or any sub that we've created so far. So when we create a new sub, then we can kind of compare whether that's bigger than what we're building, and if it is, if the temporary sub is bigger, then we return that. If the sub collection is bigger, then we return that. And then we just use rest to drop the first element from the collection and process that and send that back to be the remaining collection. So that's probably a little bit tricky to follow. So and I did have a bug in this which took me a while to fix. As you can see, there's an awful lot of code in here, and so what I did was put this function definition into a list, which turns into a function call, and then we have an argument that we need to supply. So this is a collection we're passing in. That was just the result I've just deleted there. So we've got this argument we're passing into this function definition, and we're going to call it, but I'm going to call it inside a debugger. So I'm going to what we call instrument the function, and this is going to set a whole bunch of breakpoints so we can step through each of these things so you can actually see the values inside this. So in my editor it's comma D B to start the debugger. Did that work? Let me just check. Did I not start my REPL? I might have not started my REPL. Oh, I didn't start the REPL. It helps if you've got a REPL running. I just restarted Emacs before the broadcast, so that's why it wasn't running. No questions so far. Oh, there we go. So we've got a REPL running and established. So if I can evaluate this now and give me the answer. Ooh. Oh, I think I've broken it. Oh. Did I break it? What did I do? Oh, I made a last minute change. I know I shouldn't have pushed that last minute change. What did I do? I got my brackets missed. Okay. Okay, I'm not going to live debug that because it might be slow. I'll fix that. In the previous commit it was working, but what I realized from running the debugger, and I'll run the debugger on this next iteration of the loop-recur, it passed the first two tests, but it was returning like 2 and 3 for the third test instead of 3, 4, 5, because we were dropping out of the loop without checking for the temporary sub is larger than the sub collection, and so we've kind of fixed that in here. So let's try. I'm pretty sure this one still works. Yeah, that still works. There we go. So let's just iterate this one. Sorry, let's just debug this one here. So I'm starting the debugger, and at the top you can see it's got this injected this line of control line here, so I can kind of evaluate. I can dive into things. I can see the locals. I can do the next, and I can skip over. If I've got a lazy sequence and that I don't want to evaluate by itself, I want to evaluate it in the parent expression, then I can also go out as well. So it's quite a useful debugger that's built into Cider. Thanks, bug. So I'm going to skip step 3 with n. So here it's showing me the remaining collection that I've got. So that's the remaining collection that we've got from the initial collection that we passed in as the argument. And if we do n, so it's not going to be empty, so that's going to be false. And so then we're dropping down into the loop-recur because it's false. Oh yeah, that's what I added there. So I didn't add a check. So we added a check in after we do the empty. We're adding a second check to see whether the temporary sub is bigger than the sub collection, and then we decide which one to send back, because we might process the end of it and we might have processed a smaller sub before we get to we might process the bigger sub and then the last sub might be a smaller sub. So previously we're just returning the last sub that we had, so this is just checking to see which one's bigger before we send it, before we finally return it. So we've got the temporary sub there, and that's equal to true. Why is that not showing? Oh, that's not showing the values up again, or is it showing it at the end? Maybe a little bit smaller. There we go. Oh yeah, sorry, it's hiding under there. There we go. So the temporary sub is equal to 0. So we're calling, because the first time we go around, the temporary sub empty. So we're calling the first. We're getting the first value from the collection, which is 2, and then we're going to stick that into the vector. So the whole result of that cond is to return 2 in a vector by itself. And then the temporary sub is currently empty because we haven't updated it yet, and the sub collection is currently empty. So for now we're just going to deal with the sub collections and then we're going to get the rest of 2, 3, 4, which drops the first value off there and goes, and then we go round and round again through the loop recur, this time with new values, and we've still got values to process. We're not the temporary sub isn't empty anymore, so that's false. Is the number in the subsequence we're building up, is that 1 less than the first one? So we increment that, and that equals 3, and then we compare that to the first value in the remaining collection, so we can see whether the value is continuous, like is 1 bigger than that, which is true. And so then we can add that, because we had 2 and we're adding 3 to, we're comparing it with 3, so we can now just add the 3 onto the 2 in that existing temporary subsequence. And so that's our result. And so the temporary sub is now bigger than the sub collection, so we can return the temporary sub, and that becomes the new value for the sub collection. And then we just drop the last one off there, drop the first one off, and go around again, and here that's the same. This is interesting because this is not going to be the same. So we've got 3 and 4, so that's not true. So we skip that one, and because this one's going to be equal, so temporary sub value is 4, but that's equal to 3. So this is true because this is a not equals condition. So then we're just going to start a new subsequence because 3 is the same as 3, so it's not increasing. So we start a new sequence of 3, and then we can see which is the biggest collection. So at the moment we've still got temporary sub is still bigger because we had 2, 3, and the new one would be 3, so that's not any bigger. And we just go round and round and round and round, and we can process the results until we get to the end. Boom, 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 boom. 5, and then when we process all, we're sending back the empty list. We're not sending back nil. We're sending back an empty sequence. So that way, when we test here, it's going to return true. So we know that we want to break out of it, out of the loop-recur that we've been running through. And then we can then decide which is whether the current subsequence we've got is bigger than the sub-collection, the previous bigger one, the previous one we came up with, and that is true. So then we return the current one we've been building up, because that's the bigger one. Yeah. And that's our result, and then that passed. And so I also tried that for the other one as well. So this is just the same code, and yeah, I think this is just the same code with the last one. Is this working? Oh yeah, yeah. So when yeah, so these sequences. There aren't any subsequences in this result, and so we were getting 0. Was that a yeah, which is what it's asking us to do. So it's asking us to return an empty subsequence if there aren't any subsequences. So there's no continuous values here. They're all decreasing essentially. But that, yeah, as I said in the comment here, that's a lot of work. Even for me explaining that, it's taken me about 20 minutes, and it took me about I don't know, 6 or 7 hours to write that by going through a few different approaches. So it does show that loop-recur is very powerful. You can do any kind of well, pretty much anything you want to do in Clojure you can do with loop-recur, but it does lead to a lot of code maintenance and and even just reading through what you've actually written can take a long time. So it's not the most elegant approach, and we can probably hopefully we can do better. As I'm saying here, we can find some abstractions to make this simple, and take a more functional approach. So one thing I did start looking at, let's just see, are there any questions? I'll just pause there for a second to see if anybody wants any queries on that. Nope. Okay. So my thinking now was well, what if we divided the numbers up into sequence using some kind of like partition or something like that. That's usually a good way. Partition by, group by. Those are kind of nice abstraction functions to be able to change the data, create new data that's in a better or more suitable form for us to work with. And then we could just sort by how big they all were, and maybe just reverse it and grab the first one. That was kind of one general kind of high-level approach I was thinking of, and that felt a lot more kind of functional, because we're transforming the data into a better shape, and then we can just apply a few functions there to find the right subsequence in that new shape. And so the tricky bit, I think, still is to get it into the right shape, and then everything else, once that's done, everything else is pretty trivial, because these things are very easy. So you can sort by count, so you sort by how big the subsequences are, and then that puts them into increasing order. So if like the smallest subsequences would be at the start. So if you reverse that, then the biggest sequences are going to be at the start, and then you can just get the first one of those. So that's what I was trying to aim for, and let's see how far I actually got. So let's see. So we group the numbers together, so they group sequentially. It's pretty easy just to group numbers. So in here we can use partition. So we're creating a partition of 2, so basically grouping things together by pairs. So we're grouping 1 and 0 together, and then 1 and 2, and then 3 and 0, and then 4 and 5, and we get our subsequences here, although unfortunately they're not necessarily continuously increasing. So 3, 0, that's not a subsequence, and then we've also got a split between 2 and 3, which are increasing from each other, but we've got them in a separate partition now. So one thing we can also do is also step. When we're partitioning, we can introduce a step. So what we're doing here is we're starting at the beginning, and we want to create a partition of 2, which then creates 1, 0. And then we create that as a new subsequence. But then we started at 1, and our step is going to be 1. So then we would just move to 0 and create another sequence, another partition. So then we'd have 0 and 1, and then we'd do another step to 1, and then we do 1, 2, and then we do another step to 2, and so on and so on. And so now we're actually expanding the data structures we're getting here. So we've got 1, 0, 0, 1, 1, 2, 2, 3, 3, 0, and so on. And now we can test whether each of these partitions is continually increasing. So we can see, is 0, 1 bigger than 1? Well, it's not, no, but the 0 and 1 is, 1, 2 is, 2 and 3 is. So then we could then try and filter out some of the things that the ones that the subsequences that didn't have continuous numbers in them. So we've got a data structure that's starting to get us in the right place. And so I did have a play around to try and figure out how to actually see what we could do to group them in only kind of continuous ways. So I tried to do map apply. So here we're doing apply, we're doing map, we're mapping a function, this kind of inline function, and we're going to take the values and see whether they're so are the values inside here greater than, so is 0 greater than 1 basically. And here, and it's giving us kind of a basic answer that we want. So we've got false, true, and true. So this is not increasing numbers, this is increasing numbers, this is increasing numbers. So the first one's false and the next one's true, but we actually want to return, we just want to return 0 and 1 and 1 and 2 really, and we want to basically drop 1 and 0, and then that almost gives us the subsequence there. So if we pulled out 1, 0, 1, 1, 2 and got rid of the duplicates, then we'd have our increasing subsequence. So it's looking promising, but rather than using map, we can use partition by for the same approach, but on the results of the original partition that we did. So we did this partition up here to create this a subsequence for every value that's in the collection essentially. So every value we step through, we create a pair of values as a subsequence, So if we actually do a partition by over that, it's creating us some more nested structure. And here I've just formatted it so it's a little bit easier to understand the kind of how we've broken it down. But basically we've got 1 0 here as a subsequence. That is not that's false, it's not, so 0 isn't greater than 1, so we've kept that in its own subsequence. And then we've got another subsequence where, okay, 0 1, that's true, 1 is bigger than 0, 2 is bigger than 1, 3 is bigger than 2, and it's also partitioned this as well. And then we have a break because because then 3 is not bigger than 3, so then we break, and then we've got is 4 and 5 bigger. So we kind of partitioned it into a shape that's getting closer, but now we've got too much data and we want to try and get rid of some of that, some of the things that don't meet our rule of having increasing numbers. Yeah, as we say, so we can put a filter onto this, and the filter needs to have a function. So a filter will work in. So let's do a simple filter. So we can filter, say, with odd, and then we've got a collection of 1, 2, 3, 4, 5. And so this will return only those values that are odd, only those values that are can have a true value when we apply this function. When we give the value to this function, so we give it the value 1, and odd says, okay, that's true. So filter will keep that for us. 2 is false, it's not odd, so filter discards that, and so on and so on. And then we get our answer there. So this is what we're trying to do with this filter. We've got our data here, and then we're going to basically filter out all the ones that where the number is where the first number is kind of less than when the second number is less than the first number. So we drop the 1 0 because that's true. We've dropped the 3 0 at the end of the second one, and we are keeping the 0 4 for now. I guess I could have incremented that and to see whether they were the equals, and then we would have dropped the 0 4 already. So that's one optimization I've just thought of. But we've got a lot closer to seeing, so we're breaking down our data structure into kind of almost the values that we actually want. So here you can almost see that that's kind of like the 0, 1, 2, 3 of the longest subsequence for this particular collection we're passing in. And 4, 5 is a sequence, but it's not going to be the longest one, but it is a sequence that we can create. But we still need to tidy that up and actually pull those values out of that data structure we've got. So we can sort by them, and what is I doing? Let me just oops. Yeah, so we're doing a sort by count, which isn't really kind of helping at the moment. So what we're doing is oh yeah, so it's kind of doing a little bit here where we're kind of showing that this this sequence here, oops, yeah, that sequence, that's the bigger sequence because we're sorting by count greater than, so we can make that oops. So we've got this sort by count and then putting a greater than function. So this is how we're modifying what the count does. So we want to have the biggest count at the front because we're basically going from biggest to smallest with the greater than function there. And so there we get the biggest subsequence at the front, and that's the one we actually kind of want to return. And so then we can just get the first value from that. So this kind of this is the algorithm I was trying to work towards. So we've got this partition by of partition, which is giving us the structure that we want, and then we're filtering out with the business logic of like the next value must be one larger or larger, and then we're sorting by count, and then we're getting the first value of that. And so we get our subsequence. We just need to kind of join it together, and so in my naive way I thought we can just flatten it, which we could do. So we just flatten values and we get a single sequence there, but we can't quite use flatten because we're keeping duplicates in there, so we actually want to get rid of the duplicates. And I think I tried concat as well. And so I can do it with doing concat at first and then mapping last over there, but I seem to be quite over engineered that way. So what I did was just kind of do a let, and then I've created a let with some local names and partitioned that to I've called it partitioned, and this is the data that we want in the new structure that will help us simplify our algorithm. So this is the partition by of the partitioned data, and then we filter that, and then we sorting it, and then we're concatenating and getting the first of the sorted values. So basically going over each of these values and getting the first. So we're getting 0, 1, 2, and then also adding the last of the rest as well, and we get the right result. But it's still quite it's still quite verbose, I think. Ideally, I think I'd want to separate those into, possibly separate these out into separate functions themselves if it wasn't if it was outside of 4Clojure, and that way each of the individual functions are a bit easier to do and also a bit easier to read, and also it's a lot easier to reuse those functions for similar kind of actions inside your code as well. So the kind of gold scory answer I came up with for 4Clojure was so we're getting a value for the data, assign that to A, and then we're checking to see whether X, and so we're taking in the two values from the collection. We're just using destructuring here. I didn't mention that before. So we're actually pattern matching against the structure of the data. So if we go back up here a second, where do we do? Oh yeah, here we go. So we've got our values are our number values are inside a sequence that are also inside another sequence, which is also inside another sequence, and that's where the values are. So we kind of do need to basically match that structure, and so we are filtering when we pass a value to filter, it's actually taking it's actually passing this kind of structure. So we need to destructure the kind of the second level down of a sequence there. So then we need to, so this has got two brackets. Oops, didn't want to do that. Oh, sorry about that. Where are we? Oops, I'm gonna pass it. Yeah, here we go. Yeah, so this has got two brackets here at the start before we get to the number, and so therefore we need to have two brackets before we can kind of, if we have two brackets, two square brackets here, that's going to pull out the number 1. So in the above example, that's going to be 0, and that's going to be 1, and it's going to pull them out, and then we can compare them, and so then we get the right results. So using destructuring, I think we've covered that before in previous videos. Here we're just matching on the pattern of the structure that the collection's in, and in this case it's filter is grabbing this structure, which is a list of lists. So we need to go into the main list and then into the first list of that, and then we get the number of that. So we get the two sequences. So the function is the outer square bracket is the argument, and then we're destructuring the argument by saying, okay, we want to strip out the outer layer and then strip out the inner layer, and then we've got the two numbers, and then we can process them and use that as the filter. Cool. And there was when I looked through the 4Clojure exercises, the solutions that I came up with, there was one that was, it seems to be fairly interesting. I don't think it's doing anything specifically different to me. It's creating a few ranges, and it's using subvec rather than partition, and then it's filtering by which is the which values are increasing or not, and dropping those ones that aren't, and then we're sorting by count, and again sorting by count. The biggest one, we're getting the first one, and then it's just putting that into a vector, although I don't know if that's strictly needed, as even though the values are in it's all showing that the results should be in a vector, you should be able to pass just them back as a list as well. So the answer I submitted, oh, that's the long one, isn't it? That works. We'll run that. It works, and I don't think there was any other solutions there. As you can see, actually just walking through these solutions, there wasn't anything like really obvious to. I mean, that one looks short until you realise that it's been cut off. So I'm not quite sure what the all answer is, but mapcat probably could be used to reduce some of the code as well. Most of these, this one's huge. Most of these, this is like my loop-recur, I guess. And that one's very cryptic. And this also shows you a problem with loop-recur. I mean, I appreciate they're doing this for golf score, but then you've also got a lot of names to come up with inside the loop-recur, because there's a lot of kind of local state to create and work with. So then you usually have to come up with names for that as well, and it just adds to the huge burden of making useful names for your code as you're writing it as well. This one kind of looks interesting. I'm going to try do this one as well. I'll just check to see if it's actually, does this actually work in here, and just want to make sure it's not being truncated. The results. Does it work? Oh, it works. So we've got a 4. We're going through. I guess this is the same as doing our. Oh yeah, this is the same as our partition essentially. It's creating the comparisons. It's using subvec instead of partition, and then we're going to see whether we're also applying this to see whether the numbers are increasing. Like one is bigger than the other, and we're popping the results of that into a list, and then it's using max key. Oh, I haven't used max key before. That's interesting. Let's go and have a look, see what that does. Max key. Boop. Okay, so it returns the x for which the key of x number is greatest. The multiples, the last one's returned. Okay, let's have a look. So, okay, so if we do max key and count, then it's going to return long word because that's the longest word. Okay, interesting. I guess that saves us doing count and then just grabbing first. Because this is, yeah, I guess this is a nice abstraction over doing count by the greater than, and then we were grabbing the first value by using the first function. This is just allowing us to just compose those two functions together and basically get the result straight away. Oh, that's quite nice. Might have to start using that one. Boom, there you go. Yeah, so here we're just applying max keys just to get the first, the biggest value there. Okay, cool. So as you see, this is a tricky problem. It did take me quite a while. It took quite a few of us actually to have a play around with this to see what it is. And I guess part of the reason it took so long is I got stuck with doing it in a loop-recur approach. And also I didn't quite get the partition. I mean, I got partition and I got partition by, but I didn't think about putting them both together. So that did take a while to kind of think about, because I got so partition using step. That was came to me fairly easily, but then thought, well, how do we do that? And it took me a while to realize that I could partition the results again to actually then put in to help get some kind of sense, like basically grouping those values, those subsections, sequences that actually fitted the results, and then it would make it much easier to actually filter out the ones I didn't want, because I'm actually one partition function by itself wasn't putting the structure into a way that was making it easier just to rule out those things that didn't fit the condition. So apply this sort of simple applying of whether something's greater than or not just helped us put the final touches on the data structure that I needed. Yep. So I think that's it for now. I'm going to call it a day. I've got a bit of time, so I'll stay around at the end to see if there's any questions in the chat. Feel free to put them in there. If you've got questions about this or any other challenges or any other Clojure queries you got, then feel free to ask a question, and I'll try and do something before I end the broadcast. Let's see. Yeah, so that's 53. So next time we're going to look at. We might do, if we're doing more 4Clojure, then we'll look at 54, which is partitioning a sequence, which we're going to help us understand partition a little bit more because we aren't allowed to use partition. So that should be interesting. And then 55, this is counting occurrences, but we can't use frequencies. So it's a good introduction into understanding frequencies, which I've used before when we did the regex thing about finding a most common word in a book. And let's see, I think I've done these already. 56. 56. What's that one? And find distinct items, and we're not allowed to use distinct. So those could be quite interesting to do. So in another session, I'll try and get those three done together just to see what's going on. What's this one? On simple recursion, I'll do that in a separate one. Okay. Well, thank you very much for listening, and I hope you enjoyed it. This one was quite a challenging one, so feel free, so don't worry if you actually got a bit confused. Take some time. It's good to, I had plenty of hammock time when I was going through this. In fact, I had like several kind of few hour breaks in between kind of solving this, and that actually did really help. And yeah, stepping away from the computer sometimes does make a big difference. Over the next few weeks and months, I'll be updating the books I'm working on. So I'm doing a lot of work on the Spexmax one, and then the other ones are all getting a bit of a refresh and a bit more of a restructuring as well. And if there's anything you want to see in those books, then feel free. They're all freely available. You can just go on and click on them and read through the books and suggest or ask questions about them in either the Slack channel or via on Twitter as well. So thank you very much, and see you next time. Thank you. Bye bye. I'll wait here for a few minutes just to see if anybody else has any other questions. Feel free to put them into the chat. Oh yeah, I'm going to also going to try and fix this page as well. I've got a cunning plan to actually make this actually have some data on it as well. So I'll work on this today. Hopefully this hopefully I'll get this done over this weekend and have, so you can come to this Clojure virtual study group page, and you'll be able to see all the videos there with some kind of meaningful descriptions. It'll help you find them, and I'll either have a link or you can play them inside the browser, just help you kind of and I'll try and tag them as well, so you can kind of very easily find some of the content that you actually want. If you want a particular topic, or if you just want to find a particular 4Clojure challenge, then yeah, you should be able to come to this website and find them a lot easier than the YouTube interface, hopefully. Okay, well, there aren't any more questions, it seems. So again, thank you very much for listening, and I will see you next week. Thank you. Bye bye.